All right, are you guys ready?
Yep.
Yes, sir.
All right, here we go. This episode is sponsored by Hired.com. Are you searching for a new job? That can be stressful, scary, and time-consuming. Pushy recruiters try to sell you on roles you don't actually want, and the job boards make you feel like you're throwing your resume into a black hole, never to be seen again. And sometimes you go all the way through the interview process just to find out at the very end that the salary, offer, or company culture doesn't match what you're looking for. Hired is the world's most intelligent talent matching platform for full-time and contract opportunities in engineering, development, design, product management, data science, sales, and marketing. We make your job search faster, focused, and stress-free. Instead of endlessly applying to companies and hoping for the best, Hired puts you in control of when and how you connect with compelling new opportunities. After completing one simple application, top employers apply to hire you. And on Hired, you receive personal interview requests and upfront salary information so you can make informed decisions about what opportunities to pursue over a condensed timeline. Hired offers access to more than 4,000 innovative employers, including big brand names like Facebook and smaller emerging startups. The size and type of company you want to connect with is totally up to you. And we help you find new opportunities in 17 major cities in North America, Europe, Asia, and Australia. Open to relocation? Let them know. Your privacy and autonomy in your job search is of utmost importance. And if you go check them out at the show's link, that's hire.com/JavaScript Jabber, you can get double the hiring bonus that they offer. That's $600 instead of $300. So go check them out at hire.com/JavaScript Jabber today. Hey everybody, and welcome to the JavaScript Jabber Show. This week on our panel we have Aimee Knight.
Hello from Nashville.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, and that is Eric Normand. Eric,
Hello,
do you want to say hi?
How are you doing? Oh, yes, I do. Hi. Well, maybe too fast.
Nope, you're all good. Do you want to give us a brief introduction?
Sure. My name is Eric Normand. I have a company called purelyfunctional.tv where I teach Clojure and functional programming. The main target market is people who want to transition into functional programming from their current job. And so I give them a lot of support, show them where to find jobs, convince them that there are jobs out there, give them the skills they need to do well at the interview, etc.
Makes sense. So functional programming, for a while it just felt like it was, oh, this is what the cool kids are doing. And I think that's changed a little bit. It's not just this sort of mental exercise that the cool kids are doing anymore. It's become more of a, hey, this is a direction that we can go in, and it simplifies a lot of programming for people. And so I don't know if I've, Aimee mentioned before the show, I don't know if I've heard of anyone, deeply using anything other than maybe Elm that's highly functional in a large application. Maybe you can address that really quickly.
Yeah. So functional programming is being used quite a bit at a lot of big companies. So Walmart, Amazon, eBay, PayPal, they all have Clojure applications running in production. It's also being used at a lot of banks, financial services. Like, it's actually being used quite a lot. It's certainly not at the scale of Java, JavaScript, Ruby, languages like that, where, it seems like every other person you meet is doing one of those. But there are jobs out there. Another answer to your question is that, yes, people are using it. It's influencing the sort of more mainstream programming industry at the same time.
So we were kind of talking about this, before we started the show, but you had a pretty good talk, and I'll put a link in the show notes, called Building Composable Abstractions. But I feel like, I know for myself and for a lot of developers, you go from, playing with like Haskell or ClojureScript or something like that, or Elm, whatever, in your free time, and you're like, they give you like these little, toy problems to solve. But how do you go from that to like actually building an application?
Yeah, that's a question that I get quite a lot. Usually it's phrased in terms of, how do I structure my application? Because I think a lot of people are used to using frameworks. They're used to using, like, most people don't like open up a new file called main.java and type public static void main, and like that's the beginning of their program. They start from some existing place, some existing app that they modify. So there isn't a big framework in the Clojure world. There are several small attempts that aren't really going anywhere. So it's like a persistent question. How do you actually structure your application? And my talk that you mentioned was an attempt at coming up with that. Because I think that when people are asking for structure, what they really want is a process for taking a set of features or some use cases and figuring out how to turn that into code. And, so far it seems that a lot of people who get into functional programming, they have years of development experience under their belt. Not everybody, but if I'm going to generalize, that's what I would say on average, that they've already got a lot of experience and they've already gone through I've used 3 different frameworks and I didn't like any of them and I want to kind of start from scratch and build it myself. So that is a lot of the attitude that people have in functional programming, that they don't want a framework, which I think is a detriment at the moment. We need something that's more beginner friendly. And that this talk was my attempt at coming up with a 4-step process for here's your problem. Now, what do you do to turn that into code?
So is there anything you can kind of expand on here, or should people just go watch the talk?
I can give a brief intro to it or a brief description of the process. So the first thing is there's 4 steps. First step is to develop a metaphor, some kind of real world metaphor for what you're trying to do. And when you do that, what happens is you're actually developing the first implementation, but because it's an intuitive metaphor, it's already running in your head and it's running in your coworkers' heads.
Well, I think you said this in your talk. How would you build it if you didn't have code?
Right, exactly. If someone gives you a problem of hey, we want a medical record system, but you can't use a computer, what are you going to do? Right? Well, you'd say, paper and pen, I guess, and a filing cabinet, and you just start. You can imagine it really, really easily. And if you have that metaphor at first, you've got your first implementation, and so you can use that intuition about it to answer questions later on. Okay, so the second step is then to develop the operations. So develop them, enumerate them, list them, what are their properties, that kind of thing. So you go through and you say, well, we're going to have to be able to add a new patient. We're going to have to be able to query for a patient given their name and date of birth. We're going to need to sort all of their records chronologically. And you can kind of follow along because you already understand what a big wall of files might look like and how it might work. So once you got those operations, you want to develop relationships between them. So very often at this point, you want to just jump into the code and say, well, if we're going to need to look them up by name, we need a table with an index, right? And that kind of thinking is going to limit you further on because you're already setting in stone how the thing should work. It's like saying, well, we're going to make this filing cabinet, 10 feet by 20 feet. It's kind of an implementation detail about how big the filing cabinet is. So, okay, so you figure out all the relationships between the stuff. So one relationship might be, well, when I file away a person's record, I should be able to get it back out later, right, by name. So that's the relationship between adding a patient and looking up a patient. And then you can start to say stuff like not only the relationships, but the properties. So if I add the same patient twice, well, they should actually go in the same file. I'm trying to think of another property that would be useful at this stage. But there's all sorts of little mathematical properties. Does the order matter? So if I'm putting in multiple patients, does it really matter what order I put them in? Or can I hand them out to different people in the office and they can all file them at the same time? Those kinds of properties might be a requirement, because you have multiple terminals accessing this one medical system. So once you've got all of that, you can actually write a prototype at this point. And the prototype should be something that is really easy to write, that guarantees all the properties that you want. And you can set up tests for those properties to make sure that you're not, violating some requirement. And then, okay, so this prototype, what I suggest, and this is like a functional programming technique, is to not do it in a database, to do it all in memory using functions. So the operations obviously are going to be functions, but the data should also be stored in functions, because functions are Turing complete based on, I don't want to say like the L word, but lambda calculus has been proven to be equivalent to a Turing machine. So you're not going to lose any ability that you would if you like limited yourself at this point to say, I'm going to store it all in a hash map, because hash maps are much more limited than than functions. Okay, and so then finally you can play with it and test it out and see, and actually run the tests on it, see if it does what you want. And then there's probably other requirements that aren't really, they're more like operational requirements, like it should be so fast, or it should have such and such reliability. It needs to store it to disk so we can access it later. What if the power goes out? All these other requirements that are sort of like non-functional requirements, they're operational requirements. Now you can take your prototype and refactor it into something that has all those other requirements. And my talk is kind of trying to say, like, these first three steps. People talk a lot about, I'm going to like write a first version and then refactor it and it'll be good. Except you haven't really done you didn't do the first two steps of thinking about what you want to do. You just like wrote a prototype and then refactored it, but you don't know if it's actually doing what you want to do. And refactoring is not enough. Like refactoring is like organizing your desk or cleaning your room. It can move stuff around and, put stuff in different piles, but it doesn't ask the question, what do I actually want on my desk? Right? Because you can't actually change the functionality when you're refactoring. And so at this point, you can call it a refactor because you've got all the tests, your prototype works, and you're not going to change the functionality. You're just changing these other requirements like performance, etc.
It sounds really complicated to me.
Well, anything you start talking about for 5 minutes is going to sound complicated.
Yeah.
I think that if you tried to write a process for how you developed in another language, it would be complicated too.
Yeah, probably.
Yeah, I don't know. Like, if there's books and stuff written, like, I don't know, the DDD book, domain-driven design, like that. To me, that is like one of the best books on how to actually write and design object-oriented software, and it is. I can't get through it. It's like
I have that book.
I'm the first three chapters like yeah that's great, and then it's just all about pointers and how to organize your methods and stuff, and I don't know. I just felt like I don't know. It validated why I like functional programming.
I think you started to talk about this at the end, but you also kind of touched on your talk, like, why can't you always like make the code better? Like, if maybe I misunderstood in your talk, but it sounds like you can't always write code with the thought that you can refactor it later. Is that something you were trying to get at, or did I like misinterpret?
Yeah. No, that's right. That's what I was trying to explain just now. Okay, the way I explained it in the talk is there was a system of physics called Aristotelian physics that.
No, that sounds complicated.
Yeah, it's really complicated. It's a bunch of rules and laws, and there's stuff like heavy things move slower than light things, and big things want to let me think. It's really complicated. So it's stuff like heavy stuff wants to find its natural place, which is lower to the ground, and lighter stuff wants to be higher up. And so that's why if you drop a rock, it like finds its place at the bottom of the water, and the water's natural place is on top. And you can see how, yeah, this kind of explains a little bit of stuff, right? It explains why, it's easier to walk downhill because like my natural place is down there. It explains why pushing a big thing is harder than pushing a little thing. But it doesn't explain everything. There's a lot of holes. And you can't actually refactor those rules into Newtonian mechanics. There's no way to go from this notion of natural place to a notion of the sum of forces, right? So you actually need different concepts. You need something that you have to like throw it away and start from scratch. You cannot refactor it.
So tell me if I'm like kind of summarizing this correctly, because I think you also like mentioned this. Like it sounds like, which I feel like we already know, like the most important step is not like to start coding. It's to like sit down and have like the hammock time to think about what you're doing first. Exactly.
We want to think first. And the big problem I see with that advice is like, well, as a beginner, what do you even think about? Like, what process are you going through to think about it? I've seen this joke where someone's like, the hardest part about explaining or like pair programming is that part where you just like sit and think.
Yeah.
Because there's a lot of sitting and thinking in programming.
Yes,
how do you do that with a pair?
Yeah. Or rubber ducking going back and forth.
Yeah. Like, so I guess my idea was to try to find something that people could do, which was, look, you already know a lot. You have an intuition about how things work. You should tap into that intuition. And then before you jump into the code, you should be thinking about the operations that you're going to need to do on that. And you can think about them because you already understand it. You already understand your metaphor. You already understand the filing system. And it's just a matter of like starting to formalize it and think of it in terms of operations. And then like I said, everything else is just like implementation details.
Yep. For what it's worth, my hammock time is my run in the morning.
Oh, cool. I like thinking while running.
So I did have another question written down, which like as developers, we all know like abstractions are usually a pretty good thing, but I think they can be taken too far. We actually kind of talked about this last week when we were talking about reusable components. And I think in not the talk that we've been discussing, but you gave another talk called The Elements of a Functional Mindset. And if I recall correctly, you kind of started talking about this, like, when are they good? And I'd be curious, like, your opinion. When are they good? And, like, what are your thoughts on, like, when they've been taken too far and it makes the code harder to read?
I have written so many bad abstractions with good intentions. I thought they were great.
Yeah.
And that might be like how you actually get better as a programmer, right? It's just messing up so many times. Yep. In my opinion, the ones that go too far are the ones that don't have any real basis in anything that, like, you're just making something new up, right? Like you're coming up with some new idea that hasn't been, like, there's no formal math around it. There's no, like, even physical intuition about how it's supposed to work. You just think it might be a good idea. It might save you some time. They tend to be bigger because you're like handling all these cases inside, like in the deepest levels of the abstraction. So I guess the opposite of that would be small abstractions that have properties that you can sink your teeth into. So those kinds of things are just like high school algebra type properties. Stuff like commutative, meaning the order doesn't matter. Idempotent, meaning you can do it multiple times and it doesn't matter. And these are things that when you look at like a good library, a good piece of software, or a good class with nice methods, like it feels well designed, you notice that these are the properties that it has. Like, oh, it's so convenient that I can call this multiple times and not worry about whether it's going to have multiple effects, or it doesn't matter how I group these things. That's called associativity. Or, oh, look, I have a beginning value. So like when you're adding stuff together, you can start at 0. That's great. You don't have to start with null and do this null check every time. You can start with 0. And those kinds of properties are the kinds of things that I think make better abstractions. That you can rely on these things. They're very simple properties. They're stuff you can test. They are useful, like in the sense that, like, well, when you have something that's associative, it's much easier to break it apart, work on the stuff in, like, do like a divide and conquer kind of strategy, and then put it back together. If you didn't have associativity, you couldn't do that so easily.
So is the Hammock time like when you decide if you want to make something abstract, or do you think you should wait until you see like patterns develop?
That's a good question, and I think you should do the thinking before. Now, that's not to say that you don't do exploration and stuff, but those things should be like little experiments that they never touch production. They never get deployed. So I think what you're asking is like, hey, if you see the same code repeated 3 times, does that mean it's a valid abstraction? Or like, how many times should you see it before you like dry it up? Man, if I knew the answer to that one, I could write a really nice book. I guess I want to back it up and say, like, maybe that's good evidence that there might be something there. But if it doesn't have like a known mathematical property, like I just don't feel smart enough to do math and like explore something and discover something new in math, I feel like, I have to rely on the like thousands of years of mathematicians who came before me.
That makes sense. Have you also, I'm just curious, have you heard of like, I think it was Sandy Metz, she did a talk on this, like the squint test, where if you like squint at the code and you start to see like it looks the same, like that is a trigger that you could start refactoring it. I mean, that's not necessarily abstraction, but it's more about refactoring.
Yeah, like I really respect Sandy Metz. I think one of her quotes was duplication is better than the wrong abstraction, something like that.
Yeah.
And I really think that that's something we should keep in mind. Like the worst thing is to like say, oh, these things look almost the same, so let's dry it up, but then they need a parameter that is then makes the thing more complicated, right? Like it was actually better before when they were only slightly similar. So I don't know. It's just a really complicated thing. I don't think I have a lot of good insights into that. I don't know. I know it when I see it. I don't know.
No, you gave some good thoughts.
What are your opinions on that?
In all honesty, like I know this sounds like a cop-out answer, but I genuinely believe it. Like that's why like we're paid to think through things, because it just always depends and there's not like a cookie cutter way to approach it. Like we have to think through it.
That's a really good way to think about it. That's what you pay me for.
Exactly.
If I could write it down and make a machine do it, then, I wouldn't be here right now.
Exactly.
So one of the things on our list was ClojureScript. And
yes.
We've been talking a lot about functional programming. Now, ClojureScript, Clojure was written on the JVM, if I remember right. And ClojureScript is basically a version of Clojure that compiles nicely to JavaScript.
That's right.
I'm kind of thinking to myself, and this is just me in my head, but I hear a lot of people talking about functional programming, and some people talk about doing functional programming with just JavaScript. And it sounds like they essentially ignore the parts of JavaScript that don't fit nicely into some of the features of functional programming that you've talked about. Is there a trade-off between using something like ClojureScript where it is functional or mostly purely functional versus trying to write functional JavaScript?
Yeah. So I've written both a lot of ClojureScript and a lot of JavaScript. And in terms of doing functional programming in JavaScript, you just don't have a lot of the niceties that you have in ClojureScript. So for instance, in ClojureScript, an if expression is not a statement, it's an expression, so it returns a value. Whereas in JavaScript, you have to like return from within there. And if you want to have an expression that's like an if, you have to use a ternary operator. Like little things like that where it just wasn't so well designed. I mean, as we all know, JavaScript was written in 10 days or something. It's just not as well polished for doing functional programming. Now, ClojureScript also has a large standard library. And that's another thing that people complain about in JavaScript is that there isn't a standard library. There's a growing number of functions that come with it, but you have to import something else like underscore or something like that to really
say Lodash is the standard library.
Yeah, Lodash. Yeah, there you go. It's the new one. Did it win over underscore? Lodash versus underscore. Okay. Yeah, I'm like out of the loop a lot on that. And you see, so I worked at a company that did React Native in JavaScript, and I was hired as a consultant to come in and make it more functional. So like put Redux in, make sure that things were not like setting global state all over the place, which is what I found in the code. And I would go into like, say, one component and start working on it and like remove all the state and put stuff in Redux and like really clean it up, make it nice and functional. And then I would commit it and, start working on the next one. And I'd come back in 2 weeks and the code had just totally gone non-functional again. And so I guess the moral of that story is not that you can't do functional programming in JavaScript, just that it's a lot of work. It's a fight against entropy. And you're not going to have as good a time as you do in ClojureScript. You don't have the support.
Don't wait for users to report problems. Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. You can replicate issues in seconds rather than digging through log files and having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications. It has full support for JavaScript and all other major languages and platforms. It takes less than 10 minutes to set up, and you can get a free 14-day trial by going to raygun.com and signing up today. That makes sense. One other thing that I am also curious about, I was talking to Dave Thomas from Pragmatic Bookshelf. I guess he retired, so he's doing other things, but I was talking to him this morning on Ruby Rogues, and he mentioned he's teaching a course at Southern Methodist University in Dallas, Texas. And he mentioned that he envisions that most of his students within the next 5 years are going to be writing code in some kind of functional language, and that's the future of software. Do you see that? Do you see things going that way? Or do you think that, that might be a little bit optimistic from the standpoint of, I really like functional programming?
It seems optimistic to me, but is he talking about computer science students?
Yes.
Yeah, I mean, I could see computer science departments at universities saying, yeah, if there's enough jobs for functional programmers, we want to do that anyway, so let's just teach that.
Yeah, his reasoning was that they were going to have jobs. Like these students that he has now in his class, most of them will have jobs writing functional programming, and that the functional programming paradigm is going to be something that becomes mainstream, much more mainstream, and is going to overtake object-oriented programming. And that
would be very cool. I would be very happy with that.
Yeah, his reasoning was that with Moore's law, the speed of computing is supposed to double every year and a half or something like that. And we really haven't seen that. We haven't seen the speed increases. What we've seen instead is more cores. And his reasoning was that functional programming gracefully handles concurrency because of the immutability and a couple of other features of functional programming. And so some of the high-level languages like Clojure, Scala, Elixir, and Erlang are going to kind of be set up as the next revolution of programming languages because they are basically poised as functional programming paradigm languages to take advantage of the multi-core setup without having to worry about all the headaches that come with doing concurrency in languages like JavaScript and Ruby.
Yeah, I have heard that argument a lot in the last 10 years. And I was promised way more cores than I have now. People 10 years ago were talking about 1,000 cores in your laptop. And what I've heard, this is total hearsay, but I would like to believe it, is that there just hasn't been enough pressure on Intel basically to double the number of cores every year, like they were doubling the processor speed. Instead, they've been working on stuff like power efficiency because of cell phones. And the other thing about that is the operating systems that we run on are all pretty good at using all the cores at the process level. So you're running multiple programs, each one is on a different core, and they're swapped out and sharing the cores. Stuff like PHP scales really well horizontally for each request. The request lasts milliseconds, and you just run, millions of processes. If you need millions of requests per second, you're just running a ton of processes that are all running and using the operating system processes. So I would love for like functional programming to take over the world, but I just don't see that argument really happening. Things have horizontal scalability already just by running multiple processes. That said, I do think that functional programming has a lot to teach. And the main reason to learn functional programming, at the moment at least, is to just have more tools in your toolbox. When we're solving problems and we think of an OO way of like breaking stuff up into classes and methods, like that might not be the optimal way for the problem you're trying to solve. And a functional approach, even in an OO language, could be much better.
So I guess this leads to another question. And I know that you gave us a bunch of notes on ClojureScript, and then we've been talking about at least some other things related to things that you've spoken about. But
it's totally cool. As long as you think your audience would like this stuff.
I think it's an interesting conversation to have. I guess my next question, though, is basically, if this is a better way to solve some of these problems, why aren't people finding this solution to be more common? Is it just training? Is it just people don't know it's there? Or is there more to it than that?
I think there's a prejudice, to be honest. Like when I was 10 years ago, I guess it's 9 years ago, I was getting into Clojure. I was already into Lisp. And I would mention that to people, and they would just be like, why are you even wasting your time? Like, programming is just do this step, then do that step. Why? Like, it's all imperative. The OO stuff is just putting a little bit of, encapsulation around that, but it's not doing much for it. Like, I don't know, a very jaded view of all types of paradigms. So I don't know. I think people are just a little jaded. They see stuff. What they're familiar with is like a for loop and like putting stuff into an array and using variables all over the place. And when they start to work in something like, let's say they had a class in college that was using Scheme or Common Lisp, which is actually a really common course, it feels like totally foreign to them. It feels unintuitive because they're just so used to banging on arrays with for loops. And it's also hard in a single semester to develop the fluency with those things that you already have in the for loops, to get deep enough to feel the actual benefit of them. So I think that it's just like a big hurdle to overcome that people are, they usually start with an imperative language or an OO language, and they spend so much time in it, and you have one podcast to convince them that they're going to do better with a functional language. Like it's a hard thing to do.
Yeah. I also wonder a little bit, you mentioned Scheme and Common Lisp, and I didn't take those classes in college, but I have played with them since. And yeah, I mean, I found that they weren't very practical for a lot of things, but then I find things like Elixir and Clojure, where they're actually on the JVM or on the Elixir virtual machine, and they're installable and runnable, and you can actually do stuff with them.
Yeah.
I find those a lot more interesting just because, there are capabilities there that just, I don't know if they weren't possible, or most likely they just weren't developed for the use cases that I would put them to. And so...
Yeah, for sure. I think a lot of it was, for instance, Common Lisp was developed in the late 80s. And so it just feels old. And there just wasn't much development going on that. They standardized. That's where the name Common Lisp came from. They standardized, and then they were all just so exhausted from doing the standardization process, they stopped working on it. And that is at the same point when people started moving to C++ and then to Java. And those languages were getting a lot of uptake, a lot of cash from big companies like Sun, who developed Java. I think that we are now getting into this renaissance where on the internet you can find enough people to get interested in the little language that you are developing and start to get some real uptake and, labor, just straight up work to make it better and to develop libraries and documentation and stuff. So yeah, I think that there was like this dark period in the 90s where all the languages, to develop a language required like millions of dollars, and we're now at a point where you don't need that. And there's also, what is it, doubling every 5 years, the number of programmers in the world. So even the smallest language can find enough people to make it worthwhile.
Mm-hmm.
So it's cool. We're in like a little renaissance. And I think that is one of the reasons why we're seeing a lot of functional programming stuff happening. And because a lot of functional programmers were kind of like, they had to program in Java for 10 years and they didn't like it. But there weren't any jobs in functional programming. So, they just did their job. And now there's like a choice of languages, they can do Elixir, they can do Haskell, they can do Clojure, they can do Scala. And there's kind of like, I don't know, just a lot of chatter on the internet about it. So people are hearing it.
Yep.
And JavaScript, that's the other thing. So not just the growth of programming in general, but JavaScript is a functional language. I mean, it's not as functional as some others, but it was meant to be, when it was first designed, meant to be a scheme. Then they changed the syntax, so that didn't happen. But the idea of first-class functions, like Java didn't have that. JavaScript has it. It's had it forever. Like that's a functional idea. Most imperative languages that you're familiar with don't have it. Like C, C++, Java, they don't have. Maybe C++ does now. I don't know. It's changed a lot. But JavaScript had this thing that you could pass around. And I say that JavaScript is one of the best things to ever happen to functional programming, because people are passing functions, creating functions, and returning them. They have, they understand the idea of a callback. Like all those things, they're just doing intuitively. They grow up with it, and that's great.
That's interesting.
Yep.
I like that.
So I try to keep my, obviously I'm a snob, like we all have snobbish tendencies, but language snob. I try to keep it at bay. And I think that JavaScript not only is introducing people to functional concepts, but it's also now pointing the way to stuff like React and like allowing React to exist, which is very functional. I mean, you're still in a language with immutable data structures, and it's an imperative language at heart. But you are getting people talking about functional programming and like what it means to make your thing pure, to make your component pure. So we're talking about these things now, which I think is great. People have a vocabulary around it.
Yeah. Yeah, and it's interesting. I mean, a lot of the functional JavaScript discussions that I hear usually center around React or similar technologies, or around, some library that introduces immutability or things like that. And so, yeah, a lot of these concepts are being introduced, even though the language itself, though it has functional properties to it, it is very procedural in the way that you write a lot of it.
Yeah. Like, one thing you mentioned, immutable data structures. There's some big ones like immutable JS. I would love to see someone do something like CoffeeScript, which just changed all of the literal syntax for arrays and objects into immutable versions of them. I think that would be really cool. Is just like, look, it's still JavaScript, except all your data structures are immutable. Mm-hmm. If you're listening out there, you should do that. I can't remember the guy's name. The guy who created CoffeeScript, which is, just like a little syntactic sugar over JavaScript. He gave a talk about how he did it and how, the techniques he used and how simple it was. And so it should be really, really possible to do that.
Yep. Was it Jeremy Ashkenazi?
Yeah, that's right. Also the guy who made Backbone.
Yep.
And didn't he do underscore?
Oh, really?
I could be wrong, but that's right.
Wow, what a prolific guy.
Yep, he did. He did do underscore. I was going to say, I think so.
Well, I mean, that dominated for a long time. CoffeeScript, Backbone, and underscore, that was JavaScript for the longest time.
Yeah, Backbone heavily used underscore.
I was going to say confirmed. I just looked it up on GitHub. Yep.
So is there anything else that we should dive into with functional programming before we get to picks? If people want to get started with it, is there an easy way in?
An easy way in. Lodash. Lodash is, if you're using JavaScript, Lodash is great. Start replacing all your for loops with map, filter, and reduce. It'll clean up your code, make it smaller, make it more maintainable. You won't have to worry about initializing so many variables because that's a huge bug, or source of bugs. If you want to experiment with something else, there's a bunch of other languages that compile to JavaScript, so you'll still be in the JavaScript ecosystem. One that is getting a lot of attention right now is called Elm. Mm-hmm. Elm is really doing cool things. It is a Haskell-like syntax. So if you're familiar with Haskell, you can imagine that. It's a different syntax from what a JavaScript programmer would be used to, but it's statically typed, but the type errors are amazing. They are just so clear and helpful. It's very beginner-friendly. I believe the compiler works right in the browser. You just go to the Elm site and you can start building an app right in the browser, just typing into an editor, and you can see the result on the right. If you would like something a little bit more heavyweight, you could look into TypeScript or PureScript. These languages are also compiled to JavaScript. PureScript is more Haskell-y, and TypeScript is like a superset of JavaScript, I believe. So your JavaScript is already TypeScript. Hey, you're already writing it. You can add type annotations. ClojureScript is awesome. We have an awesome community. We're very into live programming. So you type your code, you save it, and you see the result right there. You don't have to click around to get back to where you were. You don't have to reload your browser. You can just change things in the code and it shows up. I'll give Chuck some links to put in the show notes, and we'll have links to all of these things.
Sounds good. All right, well, let's go ahead and get into some picks. This episode is sponsored by Angular Dev Summit, coming September 11th through the 18th, 2017. Hi, it's Chuck from devchat.tv. I reached out to some of my friends in the Angular community to put on a completely free, no-travel conference for Ruby developers. We have speakers like Rob Wormald, Jeff Welpley, and others coming to speak about all kinds of topics in Angular. So if you're trying to learn Angular or you're trying to level up Angular, come check it out. The talks are happening throughout the day each day, and we'll have a chat available during each session. Attending the talks is free, but you need to register. Go to angulardevsummit.com. Aimee, do you have some picks for us?
Yep, I got two. So one of them I'm actually going to pick from your blog, but it is called The Hidden Cost of Abstraction from, looks like June 13th of last year, so almost a year. I actually, believe it or not, I had that saved as one of my picks before this episode, so I found it even without, prepping for today's show. So I thought it was pretty good. And then the other one, because people ask this question a lot, and we've had shows on a lot of different languages. Like we've had, I want to say 2 shows on Elm and all kinds of stuff. But just a short read called "What Functional Language Should I Learn?" And I'll put links to both these things in the show notes. And that's it for me.
All right. I jump in here with picks, but I can't think of anything at the moment.
Do you have like a horde of picks because you do so many shows?
I should actually.
I do.
I
have a huge list.
I should make somebody go back through all the shows and just make an index of all of the things that I have picked over the years. Yeah, because I've done so many shows. And then tell me which shows I haven't picked them on, and then I can just recycle picks.
Awesome.
I would have picks for years, I swear. Yeah, honestly. So one of the things that I've been fiddling with lately is the Ionic framework, which is Angular and web views to build mobile apps. I tried React Native and I thought it was cool, but I'm just not as familiar with React as I am with Angular, and so it made things a little bit easier to go that route. But yeah, I've really been enjoying it, so I'll pick the Ionic framework. Eric, do you have some picks for us?
Yeah, I'm currently reading a book by Stephen King called On Writing. It's nonfiction. It's like his memoirs, but he's also giving a lot of writing advice. And I just find it really interesting. And, I try to write a lot, so it's useful to me. If you want to write blog posts and stuff, his advice is really good. It's very practical. He's a very practical guy, very prolific. It's all about like finding an honest thing to say. And that's what makes things interesting. I've also been getting into this YouTube channel called Tested, Tested, and it's all about like a maker movement and cosplay and stuff. And I've always like dabbled in making, like I'll make one thing every 5 or 10 years, and I really enjoy it. And it's watching some of the shows on this channel. I've just been like really happy to reignite that spark, and just watching someone else make something and see them, like I'm always afraid because I don't want to ruin a thing to try to make something else because I'm probably going to ruin it, and they just ruin stuff all the time. So it makes me feel a lot better that like that's even what professional makers do.
Cool. Well, if people want to follow you, read your blog, see what you're working on, where do they go?
All right. The best place to go is purelyfunctional.tv. You will see sign-up boxes for Functional Programming Career Guide or the newsletter. I write the newsletter once a week, and it's just a bunch of links with my thoughts about them, about 10 links. I have a blog called lispcast.com, which I don't write on as much as I would like. I think that's what everyone says about their blog. But it's another source of following me. I'm not that active on Twitter, so don't follow me there. Get on my newsletter. That's the big thing.
Awesome. All right. Well, we'll go ahead and wrap this show up. Thank you for coming, Eric.
Thank you so much for having me. It was a blast.
All right. We will catch everyone next week.
Bye.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.